Hello, everyone. Welcome back. In this video, we will introduce the Knuth-Morris-Pratt stream matching algorithm. And this is also known as the KMP stream matching algorithm. This is very efficient. It achieves all of n plus n time. This is optimal because you have to compare every characters in the text and with the pattern at least one time. So n plus n is optimal. Please recall that in the brute force algorithm, we always shift one position. If the pattern doesn't match the text, we shift to one position and then shift to another position. If it doesn't match, shift another one. For the Boyle-Moore algorithm, and we compare the pattern with text from the right to left. If there's no match, and we can shift multiple positions. But there's one thing is after this comparison, you don't keep information about the previous match. So when you do this, for example, for the Boyle-Moore, and you have these from right to left comparing the pattern with the substring text. So if there's a match and then match, match, match. So all this successful match information is not retained. This information is not retained. It's just lost. You didn't use it. But you worked on this, you spent time on this. This is actually quite useful to get an efficient algorithm. So that's what the KMP algorithm comes into play. So this new algorithm will consider this information, all the successful match, this information, to determine and how you're going to shift a line in the next match. And for this, we're going to introduce this failure function. So this failure function is going to be the maximum number of positions to shift in the pattern. So this is defined as the length of the longest prefix of pattern that is the suffix of the pattern. So 0 to k. So this is the pattern. This is substring in the pattern. So just look at this. And so this is fail k. And so the length of the longest prefix, and that is also the suffix of this. And let's look at the example here. Suppose we have this pattern. So here's ABC, ABC, D, ABC. So what is this failure function here? This at this 0, well, 0 is going to be 0. And B, so there's no same character, so this is going to be 0. And C there's nothing here, 0. But look at A, Y is 1. So look at the prefix matches here, the suffix, just 1. So the length is 1. And this, the next one, B, it's going to 2. Why is this 2? AB right here, and matches here, AB, the prefix, and the longest here. And this ABC is 3. So because here's ABC, and this is ABC, the prefix matches the suffix. And here, this C is this, fail 9 is 3. So this is fail 6 is 0, but because there's no D here at the beginning here. All right, so this is a fail. So we're going to use this fail to see how we're going to do a shift. Look, we're going to compare this. Okay, so now so this is the match, 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 match. This information is very good now, but right here, A, there's no match. But we're going to slide this way here. It's a fail K. So here we know that this right here, this is, and the previous one matches. So all the way up to this. So previous one matches. Here's a K. So it's K minus 1 is matches. So we're going to see this, the largest prefix that matches the suffix. That's where we're going to shift. We're going to slide all the way down right here. So we don't have to do any comparison because we know they are exactly the same, the prefix and suffix. So that's the idea for the KMP algorithm. So this is the detailed listing for the algorithm, and there's a number of cases to consider. And so this is the algorithm, and for the and for computing the stream matching, it's animation, and this one is the computing the failure function. So the failure function can be pre-computed, so you compute it once. Let's look at this example here. So we have this is the pattern, and we're going to pre-compute the failure function. And now we're going to do this. So match, 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 match. All right, next, it doesn't match right here. But look at this. So this is the one here, is the position right here. And before this is a match. So we're going to look at this. What is the maximum here? This one here is 3. So here we're going to slide all the way for this 3 right here. And then we continue, compare this A match, B match, C match, but now it doesn't match. So here again, and this is the previous one here, it's the failure is 3. So we're going to slide 3 right here. All right, so now continue, match, 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 match. All right, so everything matches. So this is the KMP algorithm. So it is very efficient because every time and you're going to shift. And so this is the, either you're going to shift one position or you on the text, or move one position on the pattern for every comparison. And so eventually, and the time complexity is order from m plus n. So I'm going to leave the detailed analysis and algorithm and for you to study. So please take your time to look at this algorithm. That is all for this video. Thank you for watching. See you on the next video.